Hello everyone, I'm Kimura Patar Tamba. I'm from Mathematics Education Department, Pelita Harapan University. Glad to participate in this conference. Now I will present my paper entitled Digital Task Design Using Theory of Didactical Situation. Okay, the first introduction. Task design mathematics is an activity or task in a pedagogical environment that provides boundaries with which students are involved in doing mathematics. That leads to the construction of mathematical knowledge. We know and we all facing a pandemic era. So the teacher or lecturer must construct a task design that is integrated with digital technology in learning mathematics. This task design is called digital task design. In previous research and existing literature, the theory of didactical situation, or TDS, is a powerful framework for task design. But digital task design with theory of didactical situation framework has not been much elaborated. So the purpose of this research is to construct a digital task design using the theory of didactical situation. Okay, now I will explain about theory of didactical situation, or TDS. In TDS, didactical design began with looking for the fundamental situation. Fundamental situations are problems, games, or activities whose final solution is knowledge that will be achieved in learning. Or fundamental situations are problem, games, or activity whose final solution is target knowledge. This fundamental situation is set in a didactical situation. A didactical situation are ideas that mediate students' knowledge equation through problem solving. There are three different functions assigned to mathematical knowledge in this didactical situation. The first one is situation of action, or action situation. In situation of action, reservist mathematics teacher will solve problems in fundamental situation by using their prior knowledge without didactical intervention from teacher or lecturer. The second one is situation of formulation, or formulation situation. In this situation, pre-service mathematics teacher develop a solution model or making conjectures based on activity in situation of action. The last, situation of validation. In this situation, pre-service mathematics teacher means checking, testing, and validating the solution model or conjecture. Research method. This research is didactical engineering. Didactical engineering method consists four steps. The first one is preliminary analysis. Second, design and priori analysis. Third, implementation, observation, and data collection. And the last, posteriori analysis. This research conduct in calculus course. The topic of digital task design is polar coordinate system. There is 35 pre-service mathematics teacher involved in this research. Data and analysis. Data is pre-service mathematics teacher response. This data will analysis with qualitative description. Okay, now I will present the result of this study. Okay, result. Research result are present based on 4 stages of didactical engineering method. The first one is result of preliminary analysis. There are 3 findings of preliminary analysis. The first one is result of polar coordinate system epistemological analysis. Pre-service mathematics error in understanding PCS are due to the influence of Cartesian coordinate system, CCS thinking. The second one result is institutional analysis. Pre-service mathematics teacher in this research familiar with technologies such as GeoGebra and Desmos. They have prior knowledge about CCS or Cartesian coordinate system. In analysis of didactical phenomena, we find that the didactical phenomena in existing literature and previous studies is PCS teach by connected to prior knowledge or CCS. Second one is using digital task design to develop covariant thinking. Okay. Next is result of design and a priori analysis stage. Finding of this stage is the fundamental situation and a didactical situation. In the fundamental situation, we find that the fundamental situation that will be used in activity of constructing coordinate and graph of ship movement based on radar. Okay, so the context of fundamental situation is ship movement based on radar. Okay, a didactical situation. The first one is situation of action. In this situation of action, pre-service mathematics teacher explore activities and problem regarding the position and movement of ship on radar independently. Independently, the means of independently is pre-service mathematics teacher do it by themselves. In this situation, there is no didactical intervention carried out by the lecturer. There is 4 types of situation of action. The first is ship position, task 2 determine the ship position, task 3 comparing PCS and CCS, task 4 is sketch of graph. Example this, GeoGebra-applet. the explore of ship position. Okay, the second one is situation of formulation or formulation situation. In this situation, pre-service mathematics teachers are encouraged to formulate their experience in action situation. So the purpose of this situation is pre-service mathematics teacher modeling the problem solution. We can see situation of formulation in this table. So we provide question. So pre-service mathematics teacher can construct or formulate their knowledge of component of polar coordinate, difference between PCS and CCS, and drawing graphic or sketch graph. Okay, the last of a didactical situation is situation of validation. In this situation, pre-service mathematics teacher will compare, strengthen, and revise the knowledge that in construction in formulation situation. There is two kind of tasks. Task 4, determining the position of ship. Task 10 is drawing ship position graph. Example, in task 10, pre-service mathematics teacher will be encouraged to compare their result of their construction on drawing graph in PCS with simulation of ship position in GeoGebra. Okay, now I will present result of third stage, the implementation, observation, and data collection. In the situation of action and formulation, the lecturer observed the activities carried out by pre-service mathematics teacher in real time. We can see in the picture. In action situation or situation of action, pre-service mathematics teacher carry out activities according to their prior knowledge. Therefore, there will be many possible response as shown in this figure. We can see the different response for pre-service mathematics teacher. Okay, the result of posteriori analysis. Based on result of implementation, observation, and data collection, we make revision or improvement of tasks regarding to order of tasks and initial knowledge of GeoGebra. Okay, based on the result and discussion above, the conclusion of this research is that the framework of theory, the theory of didactical situation, can be arranged to produce a digital text design. The TDS framework with the fundamental situation in form of context of ship position and radar can be used to develop the digital text design. And we use GeoGebra-applet to construct a digital text design. Okay, this is the end of my presentation. Thank you for your attention. Thank you.